Good morning. It's not morning. I'm sorry. It's midday. This conversation about emojis, I'm just still laughing. Sorry, I couldn't stop laughing. I think I overuse smiley faces a lot. I think I finish every message with a smiley face. Isn't that what you're meant to do? Today we have oh no, we're behind the screen. Hold up, wait a minute. Today we have our last lecture. I can't believe we have come to the end of the 10 weeks. What a journey, what a journey. Thank you for tuning in for the last lecture. Oh, I see you must be quite young then. I do appreciate that. You're only as young as you feel. And in that case, maybe I'm still 18. But we have come to the last lecture. We are going to have some fun today. I've got Tom with me on a Zoom call because we are going to do some pair programming. So I'll be, doing some diagrams, telling Tom what to write, and so on and so forth. So we'll just have some fun with some linked lists today, which is obviously two things that you maybe have not heard in a sentence together many times, but maybe after this, that will be your idea of fun as well, just chilling with some linked lists. So today we're going to do some pointers and some linked lists. It's going to be superbly exciting. I really hope that you are all ready for that level of excitement. And if you have any questions, of course, just pop them in the chat. And
there's a question there, in fact. Question, will we have weekly test 10?
Oh.
Yes, there will be. It'll be released tomorrow. It is due a little bit earlier than the other weekly tests, I think. I don't think we've exactly figured out the due date, but I think it's going to be due on the Tuesday evening, just to make sure that we can get you back marks in time. But it's a practice exam, effectively, or it's the same question 1, question 2, question 4, and some short answer questions. So even if it wasn't a weekly test, you'd still want to do it because it's great practice, but it is also a weekly test.
Yeah. So, and we will endeavour to have, we've been pushing through all the marks. If you see any issues with your marks, please let us know. Now is a great time to do that. So because we've, getting ready for the exam kind of thing. So we want to sort out your marks as much as we can.
It's worth saying you should have all of the marks up to, definitely should have assignment 1 marks back. You should have up to week 8 lab, and I think week 8 test as well. Possibly week 8 test will be coming later this week. But if you haven't got any marks at all, if there are any question marks that you've got, please post on the forum or get in touch with us, because we want to try and get those fixed up by the latest before your exam, just so that you're not stressed about, I've got a mark that's outstanding. You won't get your assignment 2 marks back before the exam. That's because it takes a while to mark them, and we don't want to partially release some and not release others. So you shouldn't expect to get your assignment 2 marks back, but certainly you should have gotten your assignment 1 marks back by now.
All right, let's get started. Okay, so yesterday we talked a little bit about the exam. Hopefully I've alleviated your fears a little bit. I don't know, or put the fear into you. I hope not the latter. I hope it is the initial one that I said. I hope that you feel a little bit more comfortable going into the exam, and I hope that you feel a bit more confident that you're there. You can do questions 1 to 4 for sure, and then it's going to get a little bit more challenging. So I hope that you feel comfortable heading into the exam. Okay, so today we're going to do pointers and linked lists, and we are going to be going into that from, you know what, your internet is lagging a little bit, audio is completely fine. I've noticed that this happens when I have Zoom switched on. So it could be that the Zoom is just eating up all of my bandwidth. So we might have to say goodbye to seeing Tom.
The other thing it might just be is that the video will be behind the audio because it's got to go through OBS and stuff. So I'm happy to jump off camera if that's going to make it better, but it might not be a bandwidth thing so much as just a lag on processing the video thing.
Well, it's happened to, in my testing of the situation with OBS, it was Zoom. that was, I didn't realize just to what degree. So I'm sorry, you're not going to be able to see Tom. I'm going to switch off the cameras on the Zoom call. Sorry, Tom.
That's okay. I think I'll be able to live. Just barely, but I'll make it.
Okay, Tom.
I'll be back.
Apologies.
You can just like put a little photo of me there, like with thumbs up or something, maybe.
Oh, I mean, he's still there. He's just.
I'm here in spirit.
Well, how do we have such good lighting? I hate sitting in the dark. That's how I have good lighting. So hopefully this should improve the stream already. But then, how exciting, you'll still get to see me. So, sorry if you prefer to see Tom. Okay, here we go. Hopefully that stops the video from being jittery, and hopefully that improves the stream a little bit for us. I do not want to finish on a bad technical note, not for the price I'm currently paying for the internet. It has to be good. It has to be the best stream ever. Okay, where was I? Justice for Tom.
I don't know what I'm supposed to say to that.
I don't know either.
I'm still here, like in spirit. Yeah.
I think we're saying that we don't like this video of me here, but I've got a dog. Oh, you can't see my dog. My dog is sitting on my legs, basically, so you will not be able to see the dog. Unfortunate.
If we were at home, I'd be able to bring my cats out and maybe put them on camera. But unfortunately,
Tom is still here. He's just not on video.
I'm in your hearts.
I hope, Tom, you feel very, very flattered.
Oh, I do. I appreciate the F's in the chat. Thank you.
Yeah, I mean, I feel like this video. Maybe I should have worn that onesie, and maybe I would be the star of this video.
Yeah. Anyway, it's almost like you can hear me, but you can't point at me.
I can absolutely point at you. All right, here we go. Where's the code? The code is in the week 10 directory, and we are doing a VLab share, which means that we can type on it at the same time. So you're going to see some serious pair programming happening today. Can I please say again my experience? Oh my God, that is actually perfect that I deleted the head to Tom. I freed Tom.
Tom is a free elf.
Yeah. Okay, so my experience surveys, please fill out the my experience surveys. We really do value the feedback, and we use the feedback every term to make the course better and better. So it's been lovely, getting feedback so far through the different terms, and so hopefully you can pop into your My Experience survey and fill it out so that we can improve the course further on down the line, and so that it can feed into the further courses that are coming. Your tutors also value the feedback as well, because they are getting their first, tastes of teaching, and so they would love some feedback, how they're going and what they can do to improve. But also it's nice to say what they've done really well as well, because it really improves the whole, motivation and just feeling like you've achieved something as well. So if you have had, if you have something constructive to say, we'd love to hear it. If you have something nice to say, we'd love to hear it as well. So really, please just let us know what you're thinking. It will be great to have your feedback. Okay, assignment 2 extra help. I'd just like to point out again, we have our registrations. If you need extra help today, use this link here where you can book in for a ticket to go to one of the labs that are running today, and you can get some help in that lab for your assignment 2. If you want help on a Thursday or Friday, then you need to use this link over here. And again, book in for one of the labs that are running on a Thursday or Friday, and that will allow you to actually just, book in for a Thursday or Friday class to have some extra help on your assignment 2. Okay, Richard's tried to do so. It asked me to give feedback on teachers I didn't have. That's quite bizarre. It should only ask you for your tutor and for me as the teachers and then the course overall. You can NA anyone that that you do not have as a teacher. Submission deadline is on Friday at 8 p.m. That is correct for the assignment. I hope that everyone's going well. I have looked, on the Hopper queues and stuff. It looks like quite a few people have made their way through stage 1, so that's really good. I hope you're getting through stage 2 okay as well, so that will be great. Then if we already submitted an assignment before the deadline and if we submit again after the deadline, so which one will be considered? Your latest submission is always the one that is counted, unless, so as Tom said, unless you email us. Assignment, what assignment? Absolutely, we're just gonna, just pretend it doesn't exist. I didn't appear at all. That's quite bizarre. Should appear as a COMP1511 thing. Do not know what's going on there with this. So my experience is set up by a separate unit. So hopefully they've done it correctly. Okay, let's revise some pointers. How exciting. Okay, so who remembers what pointers are? Who's just going to be doing the points? Anyone who... Week 10 is always week 10 is hell week or chaos week. I don't know. I titter on the edge of madness every time. I don't know what to decide to call it. It changes every day. I am Alexandra Vassar. That is my actual real name. But no one calls me Alexandra. I am known as Sasha, which is why I've been known as Sasha. But it's like basically when you go to Alexandra Vassar, it is a pointer to Sasha Vassar. So there we go. I've just used that in there. So so that is actually me, Alexandra Vassar. Not Alexander, I'm an Alexandra. Okay. Yes. Tom, could you please post? Thank you, Tom. Yeah, thank you. Great. Am I South African? I'm not South African, but my grandfather's name was Alexander and he was called Sasha and I was named after him. So they gave me the name Alexandra and they called me Sasha just like they called him. There's a bit of a tangent and digression. And back to pointers. Okay, so what are pointers? They are those funny looking things and basically they are just another variable type in C. I would like to say they're nothing special, but they're a little bit special. But they are just another variable. What is special about them is what kind of variable they are, in that they're a variable that stores a memory address as opposed to an actual number or actual character or whatever else. They store the memory address of something. So you can then go to the memory address that the pointer is storing to see what is at that memory address. If you use the ampersand, that means gives the address off, and you use the star to dereference the pointer, which means that you use the star to go to the address off. So I've drawn this fun diagram. Well, I've tried to draw a fun diagram. Hang on, let me move my face, which is blocking things. There we go, face moved. So if you've got an int number is equal to 3, let's say we've got a variable and it is of type int, and it's got a number 3 in it. That variable, when it is created, it's still got an address and it's called number. And then let's say I have another int, house is equal to 5, not because I've used it, but because I felt like I should create another int. So again, I've got an int, it's got the number 5 on it. It has a certain address and it's called house. Now, if I say that I have a number pointer here, and you say that it's a pointer by using the star, so you say what type is stored at what it's pointing to and the star, that means that I'm declaring a pointer. So if I have this int star, that means I've declared a pointer of type int. So I've declared a pointer of type int. Because it's a variable, it still has an address of its own. but I've put inside it the address of number. So I've put inside it the address of where this number 3 is stored. So the address was 0xBBB, so that's what is stored inside this variable. So now, if I want to find out what is at this actual address that is stored in the pointer, I'm going to use a star, and what the star will do is it will access the address and go to that address to see what is in it. So if I use a star, I'll get the 3, and if I use the ampersand symbol, then I will actually travel to the address of wherever that variable is sitting. And that's just to give you a brief overview. I hope those are things that you have remembered, but if not, here is a brief overview. So now let's go to a little piece of code to just have a look at. And what I would like to do is I would like for you to have a look at this piece of code, which I'm taking a really long time to show you. Here we go. And what do you think A and B will be in this instance before I run it and print it out? What do you reckon it will be? And I can draw it as well for you, no problem. So that's a great question. What would happen if I do in star number pointer and then I try and say it's equal to number? You're not going to be able to assign that to it, because when you say in star, you're saying that's a pointer, and that means it has to store an address of a variable. But number is a variable of 3. You can't put a number into it when it's expecting an address. Okay, so how are we going processing? It will print A is equal to 10 and B is equal to 20. Okay, everyone else agreed? Does everyone else agree with that? Are people ambivalent? Just don't care. Don't care what it's going to print out. It'll print out something. Okay, are we ready? Okay, so there's a 20 and a 10. Yep, 20 and a 10. Okay, let's have a look. It's going to give us a 10 and a 20. And let's have a look why it's going to give us that. So if I go back to the lecture slides, I've drawn it out for you. So if A is equal to 5 over here, let's say I've got a variable A. So I've created a variable A that is equal to 5. It's got some address, don't care what it is. Then I've created a variable B that's 10. So this is my B and it's got a 10 in it. Then I've declared a pointer 1. So that means I've got a pointer 1, there's nothing in it, and a pointer 2, there's nothing in it again. Now I'm saying pointer 1 is equal to the address of A. So inside pointer 1, I've placed the address of A, and the address of A is over here, so that's gone into here. And in pointer 2, I've placed the address of B, so that's what's gone in here. Now I've said star pointer 1, so what that means is I would like to go to the address inside pointer 1. So I'm going to dereference it. So the address was 0xAAA. So I'm going to follow it when I've used the star and go in here and make that equal to 10. So the 5 is going to get crossed out and it's now going to be equal to 10. Then we're saying pointer 1 is equal to pointer 2. So what's happening here is both of these are pointers, which means that it's fine to assign them to each other. So I'm going to take the address inside pointer 2, which is 0xBBB, and I'm going to assign it to pointer 1. So that means that this is now going to get crossed out, and I'm going to get the address of pointer 2 sitting inside here. And now I'm going to say I would like to dereference pointer 1. So I'd like to go to the address stored at pointer 1 and make it equal to 20. And the address stored at pointer 1 is now 0xBBB. So if I do the star, I'm going to follow it to what is sitting inside this box. I'm going to cross it out and I'm going to make it equal to 20. And that's why you end up with A is equal to 10 and B is equal to 20. So the star means that we're going to follow a pointer out to a particular address that it's sitting at and find out what variable is sitting in there. And the ampersand is to get the address off to potentially store in the pointer. All right, how is that? Is that did that feel okay for a week 10? Okay, let's see another example. Let's go back to our lovely VLab. Okay, let's switch over now to a more intense example of using pointers. Okay, so what I have in here is I have a main function over here. I've got my face blocking the code so that you can't see what I'm doing. Let me just move my face. There we go. Okay. So what I have is I have a main function, and inside the main function I've got two numbers, two variables, number 13 and number 1. And I'm printing out one number plus another number plus 2 is going to be equal to num1, num2, sum plus 2. So I'm calling a function, and I'm calling the function with address of number 1 and address of number 2. And that's because my function returns an int, but my function takes in 2 pointers here. So I can't just say num1, num2, because num1 and num2 are just variables that have ints in them. So I'm sending it the addresses because that means that that's in line with what a pointer is. And then I'm going to return something from that. Okay, and then there was a big question of what on earth is the point of pointers. I always get it's very difficult to say that without sort of what is the point of pointers. And part of the reason is that it allows us to do certain things, especially when we use functions. So you know that you can't return more than one thing when you do your functions, but if you have pointers, you can change more than one thing because you can change things directly at the address that the variable is stored at. So a pointer will allow us to actually not return anything in the case of this one, for example. So this is actually, let's go to the simpler function. So this is a void function. It doesn't return anything. I give it a number, and what it does is it adds 1 to that number and stores it stores it at whatever that variable was. So having pointers allows us to have a lot more flexibility in how we write our code. It also allows us to access variables at their memory addresses, which means that we can change things directly at the source, and we're not kind of playing around with copies upon copies upon copies. And even though, if you remember when we talked about functions and what functions we'll get in that when we send something to a function, it will make a copy of it, and that's how it works. It doesn't just give it that variable. It's kind of the same when you send it an address, but the point is the copy is an address anyway. So that's why you're able to have so much more flexibility with using pointers. Okay, so in this code, back to this code, what have we got here? What do we think is going to be some of the output? Okay, what do we think is going to be the output on this line over here when I'm just doing a first bit, when I'm just doing the first section over here? So I'm doing %d plus %d plus 2 is equal to %d, and I'm giving it, okay, num1 here, num2 as a second one, and then the third one is sum plus 2, num1, num2. My God, could I have chosen worse variable names? They're so hard to pronounce in a row. So what do we think it's going to output on this line 22? So we've got 1 plus 13 plus 2 is equal to 14. I think you meant 16, but yeah, you're right. So it's 1 plus 13 plus 2. Okay, so I don't know how long the lag is. I think there's a little lag, so I'll just give you a second to answer, or maybe even 5 seconds, because the lag might be about 5 seconds. What do we think is going to be on line 22? So we've got what, line 22. Okay, great. What do we think is going to happen on line 23? When I say swap number 1 and number 2, I've given it 2 pointers, so 2 addresses. Yeah. Okay, good. Okay, and then what will it be over here in the swap? So in the swap, I'm sending it number 1 and number 2. So I'm sending it the address of 1 and 13. So, yep, so I've swapped 1 and 13. Okay. So what does that mean now? So if I've swapped them around, then what will I have now? And remember that I'm not swapping the addresses, I'm dereferencing it first. So I'm swapping what's inside that address. So what will this line output for me now? Line 24. What do we think is going to be on line 24 when I do num1 plus 1? What will that give us? This is fun. I thought Tom is meant to be my typist.
I mean, I'm more than happy to be typing. I figured for this section that you were doing the illustration, but would you like me to type?
Okay, you can do a little bit of typing. So I've got an iPad in front of me as well, so I'm like reaching out like a... You can do a little bit of the typing, okay?
Okay.
Okay, so we've got number 2. I like where that's going. So we're saying line 24, we're going to have a 2 there. So it's equal to 2, okay? And what will happen on line 25, that means? What do we reckon that's going to be equal to? What do we reckon? So far, so good. Everyone's doing well. I'm like hearing your brains explode. It's been good. Okay, 3. We've got 3. Okay, excellent. And then finally on line 26, we're going to have another little addition going on. This time we're adding number 1 and number 2. So what are we going to get in that case? And then we're going to run it. Yeah.
Do you want me to run it?
Yes, let's run it. Let's run it. We've got quite a few responses. That's good. Here we go. Oh, we've got it. We've got it. Excellent. Well done. What a team.
Teamwork makes the dream work.
Yeah, what a team. What a team. Okay, fantastic. So in this case, you've got the basics of pointers. So what you need to remember, and pointers, you become a lot more familiar with using pointers when you start using linked lists, because you use pointers so much, because a linked list is linked by using the memory address of the next one and the next one and the next one, so that you can, you're able to go on your scavenger hunt. But basically, the most important things that you want to remember in a pointer is that you use the ampersand to be able to get the address of. You use the star to dereference a pointer, which means that you want to know what is at the address that the pointer has stored. So that's what allows you to go back and to actually find out what on earth is going on in there. What is the variable that is actually stored in that pointer? Okay, very good. Okay, we are going ahead of time, which is excellent. I like that. So feel free to ask any questions, because we're going to head into linked lists. Any questions about pointers before we head into linked lists for more fun with pointers, really? Just pop them in the chat if you have any. Okay, let's talk linked lists. Okay, my face is completely in the way. I'm going to switch off my face for a second, just because otherwise you can't see what I'm trying to say over here. and there's not a spare section of space in this slide. Okay, so let's talk about a linked list. Hopefully by now you are either loving linked lists or you're hating linked lists, or, I mean, there are so many alliterations today. It's horrific. Okay, hopefully you're loving them, or getting to know them, or, you know, feeling I don't know, feeling that you would like to get to know them more. So we in this course do single linked lists, which means that we're only linking them in one direction as well. And the one important thing to remember about linked lists is that you can only access things sequentially by traversing the whole list. We cannot, like in an array, specify an index. Like I can't say, can you tell me what's in node 5? And then straight away be able to say what's in node 5. No, you have to be able to traverse through the whole linked list until you get to node 5, and then you can see what's in there. So you have to do a sequential movement through a linked list. So, you know, it takes, there is a certain level of, I'm trying to avoid using the word of complexity, but there's a certain time that is needed to be able to access every element. But the one benefit of using a linked list is that you can add nodes in as needed. So using dynamic memory allocations, when we use malloc size of struct node or whatever struct it is, but we can add a node in as we need it. We don't have to worry that we have exceeded our capacity unless that there is no more memory left in the computer, in which case you've seriously exceeded the capacity. So what that means is that, you know, you can add in nodes as needed, which is something that you cannot do in an array. If you've run out of space, if you've declared an array that's 100, elements or 100 elements in that array, when you run out past that 100, you're done. You can't really just fit in one more thing. Whereas with a linked list, you can just add a node anytime you need it. And you can also delete a node as needed. So you can use free, and that means you'll delete a node. So you are deallocating memory then as well. But what that means is it gives you the power to build up your linked list and also to diminish your linked list based on what you actually needed to do. So you can also check for memory leaks, and we'll do that today after we do a deletion question. And you can check for memory leaks by using DCC leak check. So we will run that for you today, and hopefully you've been running a little bit in the assignment as well, just to check if you have freed everything. What leak check does is it checks that for all your mallocs you're freeing as well. Because if you remember, I have said before, usually if you call a malloc, you want to call a free when you're finished with that malloc, because otherwise you've got a whole bunch of memory that you've asked for that you haven't given back. So it's, you know, a little bit greedy on the memory front. You don't really want to be doing that. Okay, so what we have is in our linked list, we always have this one pointer that points to the head of the list. Now in our code, you've often seen that, you know, pointer called head. The head is the first node of the list. So this is the head of the list here, the node of the list. But that pointer, the first pointer that you declare, points to the address of that first node. And if you want to have a linked list, you always have to have this head pointer, because you need to know where to start your linked list. Because if you don't know where to start, then your linked list is floating about, lost in space. And the reason for that is because you need to know. You need to go to each node to know the address of the next node, to know the address of the next node. So think of it like a scavenger hunt. You know, you go through looking for clues, and the clue is a memory address of the next thing that you will follow through to. So you have your pointer to the head, and then you go into the head of the list, and then you follow through to the next node, follow through to the next node, follow through to the next node. And we know that we have come to an end of the list when we've hit a null pointer. So we set the end of the list. So your tail of the list will always point to a null. So it will go to a null, and that's how you know you've reached an end of the list. Okay, that's hopefully everyone is happy with that. Okay, once again, we're going to talk about these conditions today when we will be doing our coding. but some special boundary conditions that you need to consider when you manipulate lists, okay? These are always the things that you need to consider when you're playing around. So draw a diagram, because then it's really obvious what's happening and when you're going to hit one of those conditions. One of those is an empty list. So if someone passes you a function with nothing in it, there is no list, okay? Nothing is happening. That means you can't access anything because there are no nodes in that list. So an empty list will need, a boundary case, a whole bunch of different things to occur. And then a list with one element in it. So if you're modifying that list, for example, if you have one element and you're inserting at the head, that means that you need to modify the head of the list. So depending where you're manipulating that list and what for. And then if something's happening at the beginning of the list, because it will require you to change the head. If something is happening at the end of the list, because it might require you to change the tail. And if something will not occur. So if you're searching for a particular element in the list and it doesn't exist in that list, so what happens when you go through and you can't find the condition that you're looking for? So kind of those are 5 things that you want to be thinking about when you're when you're drawing up your linked lists and drawing up your problem. Those are the things that you really want to consider that will allow you to have to be able to pass all the boundary conditions as well, for example, in your assignment. So when you've considered those types of things, especially if you're deleting or inserting, particularly, you will need to start to think about it in the terms of these boundaries. So I can see a few questions in the chat, but I think Tom has been answering them.
I think so.
Yeah, so Tom's answered them, so I will push on here. Okay, let's have a look. So I've got some little problems that might reflect some, similar problems that you might find in the exam. Why not? We're just going to practice with some problems for linked lists and hopefully give you a little bit more of a feel for linked lists. So linked list is a pretty important data structure. It's one that you will need if you're moving on through the computing degree. It'd be really good if we can give you a very solid grounding with linked lists. And again, I'd just like to say that for most of you, a linked list would be the first time that you are seeing what on earth a linked list is. An array, you kind of have a feel for what an array is because we do use them like across the board. We also use them in kind of almost in real life as well. But linked lists are quite different. So it's the first time that you're encountering this data structure. Don't be hard on yourself. I promise it will become second nature, but the first times that you start with manipulating them and playing around with them, you often, lose nodes or nodes fall out. And even me, I will often forget a boundary case until I run it. But because I've done linked lists so much, when I see a particular error, I know that I've forgotten a boundary case. So you really want to get to that stage where you've considered the boundary cases, and if you've forgotten one, that's fine as well. Just get something working so you can see where the mistake is, and always helped by a diagram for linked list. Are the nodes of the linked list stored consecutively in the stack? Okay, so Henry, I think you are confusing a little bit a stack and a linked list. So a linked list is just, oh my gosh, it's basically like, it's a huge brain fart, okay? Linked lists are, one is stored here, one is stored over here, one is just like down there, one is over here, one is here. So when you malloc the memory can be anywhere, okay? And then you're using the next struct, you're using that next pointer to point to the next section of memory. So that's how you keep track of them. Now, a stack is an abstract data type. So a stack can have an implementation using linked lists. The nodes of the linked list are still stored everywhere, but the stack is showing what is at the top, and it puts them in order of how they were stored. But all that means is that you have an order in which you're following this scavenger hunt of where these notes are randomly positioned everywhere in memory. It's a heap, okay? It's like, I mean, I don't want to say that I'm messy, but it's like my room. It's just stuff thrown everywhere, right? And that's your like linked list situation. Yeah, Daniel, they're like a follow your own adventure sort of thing, turn to page 53 to if you want to do this, and then that's your next node. They are like that. Once you understand the fact that linked lists just really allow you flexibility of how they're stored because you can just take little chunks of memory wherever they exist. Whereas for an array, I have to book in a whole consecutive chunk of memory. So if I want 1000 ints, I need to find a chunk of memory that has 1000 ints. Here I can just take each node separately in little small sections where there might be some space, and then I just link them together the way I want to. So I really like that. Yeah, well, it's a great metaphor. There's actually a meme that's like a follow your own adventure, and it's all about the linked lists, or like there's one that's like, I know a guy who knows a guy who knows a guy, and that's kind of like the linked list feel. The vibe is there because you just have to follow the people to get to the, to the right person. Okay, so let's draw some stuff. Let's code some stuff. Let's have some fun. Any questions, any comments, pop them in. So we'll start to do the first one. I am pleased that my first one is going to be an easy one because we're going to take a break after it. Okay, I'm going to hide the lecture slides. I can see Tom is writing yay coding in there, so that's super fun. Oh, he's deleted it. Well, why would you delete that? Please put it back. We want to have the feels, the vibes for coding, linked lists. Yes.
Have the vibes.
Okay, so Tom, can you just switch me over to main so we can talk about this linked list diagram that I've given on the side? Okay, so in our main, I've created a linked list for you. So I've tried to kind of prepare a few things so that I'm not drawing boxes the whole lecture, although I do love drawing a good box. So in our main, we've created a head, and it's a node 4, which is over here. And the reason that it's the second node, sorry, it's over here. I was drawing in a white pen, which is super unhelpful to all of you. No, there we go. Okay, but then I said, okay, now I'm going to say head is equal to create node 2 and then link it to the old head. So that's why my 2 is now at the head. Then I have my 4. And then I'm using insert end node to keep inserting the nodes. So I've got a 9, which is over here. Then I've got a 5, which is over here. Then I've got a 7 over here. And then I've got a 5 to finish up, which is right over here. So my list looks like this. It's going to be a 2, going to a 4, going to a 9, going to a 5, going to a 7, and finishing with a 5, which means I'm going to head to a null over here. So this is my head over here at number 2, and I'll have a pointer somewhere that will point me to that lovely node that starts me off. Okay, so the first problem, if we can please switch back to linkedlist.c, Tom. Okay, the first problem is to find the node that are divisible by a specified number. Okay. Let's say I'm going to specify that I want a node that's divisible by 3. Okay, so I've got a function in here that has a return of nothing, and we can change that as we see fit depending how we're going to use this function. But because I'm printing in the function whatever the data is in that node, I'm going to have it as a void. But, depending what you're doing, you could have something else. You should have access to the code. Did I not? Can you chmod Tom? I really wanted to call you Sam. I don't even know a Sam. Can you please chmod the linked list folder in week 10? I think that's what I didn't do. I chmodded the files, but not the folder.
So I'm just checking. Week 10 is accessible.
Is the linked list folder accessible?
Yeah, cool. That's the problem.
Yeah. Thank you very much. Okay, there you go. You should be able to see it now.
Just trying out to access it now.
Okay. Yeah. Perfect. Thank you. Okay, that should all be visible now. Excellent. Okay, good. Okay, so actually what I've done is I've copied the linked list stuff from that we had in week 7, and then we're continuing working in that multi-file to also give you a little bit of structure for linked lists as well, so you can see different things that you can do. Okay, so let's say that we're trying to find nodes that are divisible by 3. So I want nodes that are divisible by 3. Okay, that's my condition. So what I'm sending to my function is I'm sending it what I want to be able to divide by. So that's my an int that I'm going to be dividing by. I want to say divisibling. That's not a word. Dividing by, and then I'm also giving it the head of the list that I'll be searching for. That I'm going to be searching through to get to wherever I'm going. Okay, so let's have a look. So what does that mean we have going for us? Okay. Yeah, maybe I should have called it something better. But the number that we are testing divisibility by, in this case, I should have called it something better.
Do you want to change it?
Yeah, let's change it. Data, because we've used data everywhere else. Divisor. There we go.
That's an excellent name.
Okay, hopefully that makes it a little bit easier to understand what's going on. Yeah. Okay, and then the struct node head, we're just giving it the head of the linked list so that it can follow the linked list. Okay, so let's open it up to the chat. My favorite part, and I've seen some of you doing it, I've looked through your labs. Can we please have a node that we will use to traverse through the list? What will we do there? How will we traverse through this list? How will I traverse through? So I want to be able to move through this list like this until I find something that is divisible by 3. And when I find something divisible by 3, I want to be able to print it out. So, yeah, so we're going to set a current node. Fantastic. Yeah, so everyone is like super into the struct node current is equal to head. I love that. Excellent. Very good. Okay. So we've now got a current node which is set to head. So we've basically got the pointer copied into a current that we can now move through our list with. Okay. How we now want to traverse through this list. What do we think is going to be our condition that will allow us to traverse through the list?
Some might say this is a recurrent problem.
Yeah. Yeah, so we want to, oh God, Tom, I just got that. I didn't, yeah. Tom, you ready to be a dad with that kind of joke?
I love a good dad joke. I used to get feedback in my experience. It was just like either more dad jokes or less dad jokes. It was great.
There we have it. Okay, so we want to be able to traverse through the whole list. Where do we want to where do we want to stop? So we want to be able to traverse through until we get to the end of the list. And when we get to the end of the list is when we want to be able to stop. And that means that, we've gotten through the whole list. So how do we get through the list? What will be our condition to traverse through the whole list? Yep, after the last node. Excellent. So is it going to be current is not equal to null, or is it going to be current next is not equal to null? Yeah, well done. So whilst current is not equal to null, and it's not current next because we want to get to the very end of the list. So when we exit out of the list, oh, I didn't mean to erase that. When we exit out of the list, the current is going to be equal to null, okay? We don't want to stop on the second last node. We want to be, when we exit, we're at the end of the list. And that's why we want to go to current is not equal to null, because current next is equal to null will stop us over here. And it won't run through the whole thing. Okay, great. Okay, whilst current next is not equal to null, we want to do something. So we want to stop and print out a node when it is divisible by 3. Okay, so how are we going to check for this condition? How will we check if something is divisible, if our node, whatever is stored in the node, is divisible by 3? And PS, look at all of you using pointers in the chat, all those arrows. Okay, so I want to go through and then I want to be like, oh, I found something divisible by 3. I want to stop. Yep, well done. Excellent. So we're going to use the lovely percent symbol, which doesn't mean percent. It just means modulus. So we're going to test if current data, because current data will allow us to access each one of these lovely things that are stored inside the data member of the struct. So if current data modulus 3 is equal to 0. So, and what do we want to do with that 3 that Tom has put in here? Because this 3 right now is a bit of a constant. It cannot be changed. Whereas we are sending to our function, we're sending a number that could potentially be changed each and every time. So what would that 3 be if we were coding it out? Yeah, divisor. Excellent. So if current data modulus divisor is equal to 0, which means that if I have no remainders when whatever is stored in the node, whatever data is stored in the node is divisible by 3 or by whatever number it is, then I'm going to print out what that node is. And then I'm going to move on. I'm going to move on to the next movement. So I'm going to say current next, which is what's going to keep me moving across and moving down this list to get through the whole list. Okay, so do we reckon that this is, I think this is it. I think we've done it. I think it's fantastic. So let's go to our main and let's uncomment out find divisible so that we can test it. Fantastic. Thank you, Tom. And can we go, I think, can we just check in linked list.h that the function is defined? I can't remember. I think I did. Yeah. Yeah.
Let's just change it so that it's not the same.
Exactly. Let's just change it to divisor so it's all consistent and save that. Thank you very much. All right, let's run it. Oh. Yep. Excellent.
How do I compile this? Because there's more than one file.
How indeed do you compile it? What should we compile? Should we compile the .h? Should we compile the .c's? What should we do?
This is why you pair program with 70 people.
It's so fun. No, but I have asked this question quite a few times. I think it's the lag that's killing us. Or maybe not enough dad jokes. People are not feeling the vibe.
I see that might be a problem.
Here we go. All the C files. Yes. Well done. So let's compile all our .c files. Can you please comment out all my other functions that are not completed in linked list.c? Because that looks pretty miserable.
Where are we going? Linked list.c.
Yeah.
Landing back down here isn't.
Just the whole lot. Yeah.
Oh, it'll complain about those files.
Yeah.
Oh wait, no.
Just do the whole lot. Yeah. Okay. And the divisibility one as well, Tom.
That one as well. Yeah.
Yeah. Thank you very much. Okay, let's try this again.
Save and go back and compile.
Excellent. And now let's run it. Ah, fantastic. So it's bringing out the 9 for me because 9 is the one that's going to be divisible by 3. How fantastic. Should we try it with 2 numbers? Can you just go to the main, please, and change one of those numbers to, yep, amazing. Thank you very much. Let's try it again. Now, if I were running the tests myself, if I didn't have auto test, like say I didn't want to rely on all the auto test, what numbers do you think I would check in that list if it was spitting them out at me? What numbers do you think would be good ones to check? So it's still, this list is still traversing through the whole list, so it can do multiples. But which numbers do, 0, so you're saying okay. And what else would be good to check? 0 is a good one. Negative numbers, yeah, excellent, well done. Let's do a negative in there, excellent. What else? 0 to 2, okay, can we pop, excellent. What about putting something at the end of the list that will be also divisible? Let's put something at the end of the list. So let's do very end of the list. Let's do a 9 there. That will cause a, yep, okay. So always check if something's happening at the end. Always check if something is happening with all of those. Check for decimals. That's definitely going to fail. That is an excellent thing to check. I agree. But yeah, it will fail because we've got ints everywhere. That's the way we do. We just try and think of what will be a disaster that leads to an absolute, debacle. Oh, how fantastic. So in this case, it's picked out a 0 as being divisible by 3. It's picked out the minus 12, and it's picked out the 9, which is right at the end. So it's looking good, unless, is 0 really divisible by 3? Oh, let's have a mathematical debate. No, but you can, in an exam setting, you will always be given certain assumptions, and you will be told in those cases that are a bit off, you'll be told what to do with those kinds of numbers.
There's one other edge case that might be useful to look at here, which is one of the ones that was on your slide a few moments ago.
Yeah. Oh yeah, if there's nothing in that list. That is what happens if there is nothing that is divisible by 3.
So I'll just put null in there, which
means
it's an empty list.
Okay, so is this going to break us as well? So if we're giving it a null pointer to the list. So now we're sending our function with a 3, but also with a null. So we're giving it a head pointer null.
We're putting null in here.
Yeah, so we're telling it our linked list starts at null, which is really a horrible thing to do. It's so mean. Obviously, I think you can I think you can see that will give us nothing. So let's just check. Let's run it. Let's break it. Let's save the files. Let's compile it. Excellent. No, all saved. Okay.
Change that to null. That's the problem there.
Yeah.
Alrighty. There we go.
Perfect.
Cool.
Okay. And so what it's done is it's given us the X from the print list, and it's not printed out anything at all as well. And what about if there's nothing to print out? Then you would check that case as well, in case nothing in that list is divisible by 3 also. So what would you output?
Here we could change this to a 1. That can be a 4. And that can be a 7.
07, are we doing 007? That felt like it.
The fun is that would be an on brand with the new Bond movie. That might cause some interesting problems.
Okay, fantastic. So it doesn't output anything. So it is working as we hope. And we've checked a few little things going on. All right, let's have a little break, and then we're going to do something a bit harder. We're going to delete, and then we're going to insert. We're going to have some serious fun. So let's do. And when we delete, I think Becky asked in the forum an excellent question about deleting and what's going on. So we are going to actually, we're going to make that case happen so that you can see what actually happens. Okay, let's have a tiny little break, and then we will recommence in 5 minutes. Hello, hello, we're back. We're back. Okay. Let's play some more with the linked lists. Very excited. Okay. I'm actually very excited about the James Bond film. I can't wait to go see it. Yeah, so Sienna, Tom is about to answer to your message as well, so that to clear up what to do as well. Thank you. Tom and I were just having a discussion, Daniel, what it will do if you percent zero, and you shouldn't be able to divide by zero, should you? Yeah. Okay. Well, there we go. That's a bit exciting. Assignment makes me want to get pizza. Yeah, I feel like I've been hungry for like 5 weeks because of that assignment. Okay, let's get back to linked lists. Otherwise, I'll just start talking about pizza. Here we go. Hopefully no one's realized how easy it is to distract me from whatever I am doing. Okay, here we go. Let's now take it up a notch and not just look for divisibility or not just comb through a linked list. So that's a common, actually I just want to say, so that's a common question 2 in a linked list where you have to traverse through the linked list and look for something, look for some sort of condition. So I feel like, that's the easier part of working with linked lists where you don't have to insert anything or delete anything. And then, you kind of just, look through it. So you traverse through it. So make sure you understand how to traverse through a linked list and look for a specific condition. And then think about those boundaries. What happens if you haven't found that specific condition? What happens if there's a weird thing that you're looking for, if that's part of the assumptions? And what happens if it's towards the end? What happens if it's towards the front? So if you're looking for something that's at the very end, if you had a current next is not equal to null, if you test it out with the very end node, it will tell you if you're traversing through the linked list to the right node. So that's why we look for something at the end. And at the beginning as well, it tells you if you've started in the right place as well. Okay. So Thea, can the next assignment be KFC themed? Oh, we've got a healthy sushi train next, I think. Or maybe we'll have, I don't think I can do 5 weeks of wanting KFC. It would just not be a pleasant, because I don't even like KFC, but it smells nice.
There would be some great branding opportunities though. Maybe we could get like a zinger bucket brought to the last lecture or something.
Oh goodness. Well, wouldn't it be fun to be back in the theatres? Okay. Yeah, it is very thematic. I feel that too. Okay, and let's delete. Okay, so now we want to be able to comb through the linked list, and let's say we want to delete something that is divisible by 3. So again, I'm going to use this lovely example. I'm trying to write in a white pen again. Okay, so I want to delete any node that is divisible by 3. So what I'm going to do here is I'm going to think about how that's going to happen. So obviously I want to traverse through the list and I want to get to the node that I want. So right now I have 2, 4, 9, 5, 7, and 5. Oops, and null. Okay, so I want to be able to traverse through. When I get to a node that is divisible by 3, I want to be able to delete it. So that means I'm going to delete the pointer to it, and I'm going to point this one to the one that's 1 over from it. Okay, so that means when I get to this node, I want to delete it, I really want to know what the previous node to it was, and also the next node to it. So the next one is pretty easy, but the previous one is not as easy unless I keep track of it, or I can do it with current next, and so on and so forth. So it's up to you guys how you choose to solve this problem. There's obviously easier places to solve it, easier ways and slightly more complex ways. But first of all, let's think of our boundary conditions. What happens for the first boundary? If I get a list that is a null list, it's empty. What happens if it's an empty list? Okay, so the first boundary let's think about is if we have an empty list. Okay, what will that do for us? If I try to search through an empty list, what should I do there? So that is the first one I want to consider. Okay, then the second one I want to consider is what happens if I get an item, if I get a node, just one node, and what happens if I will then have to delete that node? What will happen then? Okay, so only one node in the list. Okay, then, oopsie daisy, okay. Then my third thing, I'm going to move it over here actually, okay, that I'm going to consider is what happens if I have to delete the head. Okay, because if I delete the head, that means I'm going to lose the start of my linked list. So I need to be able to have a new head, and that new head has to go to the one that follows, the node that follows the head. Okay, what happens if I'm deleting the head? And what happens if I want to delete the tail? So these are things we're going to think about when we start writing our code. And if I don't delete anything at all, if there's nothing to delete, so you know. That's probably the easiest case of all, if there's nothing. Then in the exam, do we have to write a header for each program?
So every file that you get given in the exam should come with a header already in it.
Yeah.
Just so that you're sort of starting something.
Yeah.
We'd encourage you to update the header just so that it's clear to you what you're doing, but there aren't specific marks for it.
Yeah. So again, just keep it neat in the exam. Even though there's no style marks, keep it really neat because we're marking them manually. If it's easy to read, it's easier to mark.
Just imagine Sasha being on the 300th exam question that she's marking. Would you like Sasha to have great style or to have to read bad style?
Yeah.
Think about that.
Yeah. Yeah. Think about me. And think about how distracted I would get if it had bad style. Okay. Okay. All right. Excellent. Let's get back to our list. All right. So let's do our boundary cases. Let's do the first one. What happens if it's a null list? Okay. So let's look at this one first. The null empty list. Okay. How do we check if it's an empty list? Someone said, do we need to comment on our code? You do not need to comment on your code, but if you're doing something complex, that requires some manipulation, please write a small comment on it. Again, if I'm on the 500th question marking it and I don't understand what you're doing, it's not going to, I'm not going to be able to give you many marks. Okay. Okay, Tom, could you please, actually, no, I've asked the audience, what do we think? Yeah, okay, so someone said if head is equal to null. So we check if head is equal to null because what that does is it checks that we have a list, okay? So there's something in the list. There's some nodes in there. And if head is equal to null, what will I return? If you notice, my function is returning a struct node star. It's returning a node. What should I return? What is there to return if my head is equal to null? So if there's nothing in my list, what will I return? Yep. So are you saying return null? Yep. Okay. We can absolutely return null. Excellent, because there's nothing there. Okay. Now, what happens if we have, or you can return head as well, because the head is equal to null as well. So either one or the other. Yeah. Same. Next one. What happens if there's one node and that's the node that I'm going to delete? Let's do that one next. So what happens if I'm deleting the head node, the first node, the head node? What happens then? Okay, so we're deleting the first node. What happens then? How will we check if that first node is going to be the one that we want. Okay, who's got thoughts, ideas, suggestions? The list gets empty. The list does get empty. It gets very lonely. But how will I check if it's if the first thing is my match? If current next is equal to null, set head as null. So you're saying if current next is equal to null, you can set, okay. Yeah, okay. So that's, but how do I, so yes, okay, excellent. Okay, so someone is saying yes. So I want to check if it's divisible first. So let's check divisibility first. And someone's written, yep, so if current data, we don't have a current yet, so I'm going to do it with head to start with. So if head data is divisible by 3, so if its percentage divisor is equal to 0, then we have said that we're going to do some magic. We are going to delete our node, okay? So everyone knows that everyone knows. I hope that you remember that to delete a node, you free it. You free it from its prison. Okay, so let's free the node. Okay, what happens if I free this node? What happens then? I lose all control of this list. I no longer know where on earth this list starts, and I can no longer traverse this list. So what I need to be able to do is I need to be able to still hold some sort of piece of what happens. So where is the next pointing to? So if I'm deleting the head node, okay, I've freed the head, but before that, I want to know what on earth is sitting inside head next, okay? Because that will tell me if there is anything inside my head. So if I have a list and it's only got one item, let me move this down. Oh, did not mean to do that. I'm terrible at using this whiteboard. Okay, so let's say I have one node and that node is going to be deleted. So I've got some sort of pointer pointing to it. This is my head. If I free it, I no longer have anything to grasp. Yep. So someone's saying, yeah, let's use a temp to store what is sitting inside this next in here, because that will allow me to counteract that. So if I'm deleting the head, I'm going to point it to the next thing in case there are other items after it as well. So I'm making a new head, that means. Okay. So struct node, let's call it new head just to be really, creative. And that struct node new head is going to be equal to whatever is sitting inside my next. So if this was over here, if this was a 9 and thing that I wanted to delete, then what would happen is I'm going to store this address in a temp. And what I will do then is I will make this the head, and then I'm going to free this node. So that means I've done something at the very start. So that means struct new head is going to be equal to whatever is sitting in head next right now. So it's going to be whatever is sitting in this item over here. Then I'm going to free the head. And what will I return? What will I give back to my function now that I've got this wonderful new list? What will I return back? I wonder if the lag is 5 or 10 seconds. I think it's 10. New head. Excellent. Well done. So I'm going to return the new head because what I'm returning is this thing here. Because inside my new head, I've stored the address of what was inside my next, which means that my new head has the address of this node here. And that means that this is now where I start my list, okay? Because this node no longer exists. Well done. Okay, great. So now we've considered two things here. We've considered what happens if we have an empty list and we just return, head or null because there's nothing in that list. And what happens if we're deleting the first node of that list? So what happens if we're going to delete the first node? Because then we need to make, a different head of that list. Okay, next one. So Thea's asked a question. What happens if head next %3 is equal to 0? Would that still be fine? Do you mean head next data? So now you're saying, I understand what you're saying. So what happens now if the next head is also divisible by 3? That is a superb question. I love it. That's a great question because you've got a new head and here you have this if statement. So you might run into some problems. We will definitely test that. That is an excellent thing to test. Well done. Okay, so let's do that. Tom, can you please write in the comments for us to test if we've got a list that's 9, 9, and then 5 something, 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 so that we can test that case, and that is an excellent case to test. And whatever else. Okay, fantastic. Very good. Good thinking. Okay. Let's now do our normal case of where we will delete something. It might be in the middle, and then we'll see if that also accounts for deleting something at the end. Okay, so let's have a look for our normal one. Okay, so let's say I've got a list and the 9 is sitting politely in the middle of the list. It's not challenging me at all, which is very nice of the 9. So let's say the 9 is over here. Okay, so what I want to be doing in this case is I want to start at the head of the list. I want to traverse through the list. Now, if I get to this node that is divisible by 9, I've lost track of what was previously to it. So it's going to be hard for me to connect it up again because what I want to be doing is I want to be going to the previous one, changing this to point to this node here, and then I can delete my node. So one solution to this is to keep track of a previous pointer as well. So to keep track of not only the current node, but also the previous node when you're deleting, because that gives you the flexibility to move around much faster, much easier to write the code. So let's try it out with that. So Tom, if we could please have 2 ways to traverse the list now. Well, not 2 ways, but 2 pointers that we will keep track of as we're traversing the list. And I would like to have a current pointer, and the current will be set to the head of the list because that's what we usually do. But what do you think I will set the previous node at? So if I have a struct node previous pointer, what will it be pointing at? So my current is currently sitting over here pointing to the head. And what does that mean? Where will my previous be to the current? What will it be pointing to? What do we reckon? A few ideas, and a few great ideas. Well done. So my previous to start with is really previous to my first node, and that right now is nothing. It's just there's null there. So well done. So my previous right now is at null. But Daniel, you're right, and Abhishek, you're also right in that as we start traversing through the list, when we move on to our current one across, my previous is going to be equal to the current because I'm going to be moving across. Okay, fantastic. Let's try using these types of nodes to traverse through the list. Okay, so let's have a loop that will take me through the list and will get me to my node that is going to have this lovely situation here that I'm going to be divisible by that number that I've sent across. So what do we think is going to be our condition? Sienna, that's a good question. So the previous we usually set to null and then we increment it. So there is a reason why you will set it to null and not head. And Tom would love to, I think, make a dad joke in explaining it. So I'm going to let him do it. Tom?
Yeah. The main thing I was going to say is because hopefully we never have to use that previous on the first iteration, like it's going to get overwritten by whatever current is going to be. It might not matter too much, but we use null. The recommendation is that you use null here. First of all, because it kind of makes sense that there's nothing before the head, so null kind of makes sense there. But also because if you make a mistake and say you accidentally do something wrong and you use previous where you shouldn't, instead of getting some weird behavior where current is in two places and you get a weird loop, because you've got a null there, you're much more likely to get an error. And it's kind of nice if you get an error because you know, oh, I've done something wrong, as opposed to I'm getting an infinite loop and I don't know why, oh my goodness, what's going on. So we recommend setting previous equals null because it just means you're more likely to get an error if you do something wrong. So it's kind of like defensive programming almost.
Yeah. So you'll try, and if you try and access it, you'll get the null pointer error, which I'm sure you guys have seen whilst doing the assignment and are hating very much. So good practice to set it to what it's equal to, which is null in this case. But that's a great question. Okay, fantastic. So we've got our one section of our while condition. I like it, whilst current is not equal to null. So if we set current is not equal to null, that will get us to the end of the list here. What that will mean is that we will be able to go all the way to the end of the list here at null. Okay, so we will finish. And that means that when we exit outside of our while loop, it's going to be the current is going to be equal to null. Okay, so if we exit our loop and say that the current is equal to null, no, let's not do it right now. Let's do it next. Okay, no, I won't jump ahead. Okay, so what we are searching through, we're searching for two things. We want to make sure that we're not at the end of the list, but we also want to be able to search for this condition of divisibility because that's what tells us when we need to stop and delete. So one way to do this is, you can use an if statement and, you can loop through and then if you've met this condition, you've got it. But another way to do it is to basically say, okay, if we're sitting in this loop, if I'm not at the end of the list and I'm not going to be divisible by 9, I'm going to keep moving across until I am. So when I exit out of my while loop, either one condition is that or the other kind of thing. So how would we search through? So right now we're searching through, we're already taking care of, when we say while current is not equal to null, we're taking care of being able to traverse through the list. But how do we then also continue moving as well if we're not equal to, if the divisibility is not there? So we want to be traversing whilst the divisibility is not there. What do we reckon? Feel free to say no idea as well. So I'm not just like, oh, the lag is terrible. And that's okay to not quite know yet. I just want to get to the deleting. I'm so excited to just free something. Yep, well done. Okay, so we're gonna test for two things. We're gonna test whether we are at null, which means we want to stop if we're at null, and we're going to test for whether or not our node, the data in our node, is going to be divisible by 3. Oh, well, by the divisor, but by 3 in this example. Excellent. Okay. So that means that when we come out of the while loop, there is two potentials, okay? Either we are at the end of the list, which means that our current is equal to null, or our current data is divisible by 3, okay? So either we're at null, and that means that we haven't found anything in that list, or we are at current data divided by divisor is equal to 0. So we found the node that we want to delete. Okay, So let's go inside our while loop. So whilst those conditions are both true, what we want to be doing is we want to just be traversing through the list, okay? So we want to keep going. So we already know that to move the current pointer, we go current is equal to current next, which will allow me, if the current is here, it will allow me to jump across to this one and allow me to jump across to this one and so on and so forth, okay? But right now, we are also driving, we're driving the train with 2 pointers. So I've got the previous is over here and my current is over here, okay? So if I've moved my current across, so my current has moved 1, then I also want to move my previous one. So what should my previous be set to? What do you think? Catherine, in this case it does. So it's like we're looking for the first node that is divisible by 3. Well done. That's good spotting. And there are ways to continue looping through the list as well, obviously. Yep, so previous will be equal to current. Well done. And then we're going to move across the current. So Tom, if we can, yep, previous is equal to current. And current is going to be equal to current next. Excellent. Okay, so now let's take care. Can we also just return an if condition? Potential, yes. Depending, I'm not really sure what you're asking yet, but we'll go back and examine what's going on here once we play around with it a little bit more. So now let's test what we came out of this condition with, okay? Because when we came out of that while loop, and Tom, could you please enter a few times so that we get to see the screen a little bit better? Yep, perfect. So there's 2 potentials when we exit out of that while loop. Either that current is equal to null, so we're at the end of the list. So now if we do any deleting, we're going to encounter some problems because there's nothing happening. We're at the end of the list. Or we actually need to delete. So the first thing that we can take care of is we can take care of what happens if we came out of that while loop with the current is equal to null condition. So what happens if that current is equal to null? What would we return if the current is equal to null, which means that we haven't found anything in that list that is worthy of deleting? We don't have to free anything. So what would we return? What do we reckon? Yeah, return head. Well done. And then we just return the head of the list. Excellent. Okay, we'll return the head. So now we've taken care of that case. That means we are finally ready to delete something. Okay, and if we're deleting our 9, so that means that if we've come to this point, that means we have our current is sitting over here. And our previous is sitting over here. So what we want to do is we want to delete the current. So we're going to free the current. Okay, so we know that. So Tom, could you pop in that we're going to free the current? Current is done. Goodbye, current. But before we delete the current, we really need to kind of do something else, don't we? We need to redirect the previous node to point to the one that is in here. So before we've deleted that current, so because we don't want to lose what it's pointing to, so that will be a little bit of a disaster. So what we want to do is we want to be able to get what this address is out of our current, and we want to put it inside here instead. Okay, so what we want to be doing then is our previous next, because this node is currently the previous, and the next part of it, we want to point it to whatever was sitting inside the current next. So our previous next is going to be equal to the current next. Now that we've done that, this node is now pointing over here. So I've gotten rid of this link in the chain. And what I can do now is I can just free this current. It's done. It's had its time. It's had its heyday. It's over. It's gone. Okay, great. That should be working for a few conditions now. So let's have a look what it does when we compile it. Let's see if we have met everything that we need to meet.
Should we change the main too?
Oh yes, that would be fantastic because the main is now different. So let's do delete divisible and print list again, where we're going to print the list. And can we please
put in some nice numbers just so we can start off with an easy test?
Yeah, so Daniel, so the problem to start with, let's delete the first instance and then we'll talk about how you would be doing it when you go back to the list. Yeah. And often in the exam, you will be asked to delete or to insert or to do something once, okay? So we're not gonna, twist your brains and hope for the best. Okay, so let's have a linked list. Let's run it. What's our linked list? 2471654. So we had one node in the middle, 6, that is going to be deleted, and indeed it was. Okay, so now let's check a few of our boundary conditions that they work. So Tom, could you please put something divisible in the main at the head?
Absolutely, I can. So we'll change this one so that it starts with a 9, let's say.
Yep. Okay, and let's run it. Oh no. What a disaster.
Uh-oh. Oh no. What did we do? Should we have a look at the code?
Yeah, so let's have a look at the code. So what's going on here? What's happened? So where was the error?
The error was on line 33. It was here.
In line 33. Okay.
This is an interesting.
And what's our error? malloc use after free. It was in the printing. Okay.
Yeah. So it's always annoying when that happens, when there's an error in the printing.
It is that printing that really, I hope no one's printing has been giving them problems in the assignment.
So it's a malloc use after free error.
Mm-hmm.
So which condition was it that we think caused it?
So what do we think has caused this situation to occur? What do we reckon? Hey, someone, I'm just going to the chat whilst we're doing that. What I meant was instead of using the and in while statement, we can also just return head in the if condition so the function will exit, right? Yes, you can definitely do things a number of ways. How many people attempt part 4 in the assignment? Not many. Need to update the head of the list in main. Head is equal to delete. Excellent, well done. Well done. Someone's realized what the issue is. No, hang on. Yeah. 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 So let's fix it. Let's fix it.
Okay.
Someone's found it, so let's fix it. So if in our main, so if you go back to the main, we've deleted a node, but we've deleted our head. So what happens now when we print list head is we're printing the head of the list, which is that first node that we've deleted, which is not possible. So we want to be able to have our new head. So instead of delete divisible, the function returns a head. So we want to be able to capture what on earth it's returned because it's going to return a new head to us. And that is one of the reasons why you want to return the head as well in that situation where you're deleting the first node. Yeah, exactly. Well done. That's right. Okay, let's do it again. Let's run it. Ah, fantastic. And we can see that it's deleted the first element of the list. Fantastic. Okay, now let's try the last element of the list. Will it delete the last element of the list?
Before we do that, because it'll require a few changes, do we want to look at that case that was in the to-do?
Yes. Let's do that. Excellent. Yeah, okay. So let's do that, the one that Theo suggested, which was a great case to try. So can we please do a 9 and a 9?
Can I get rid of this just because I think it's going to be confusing?
Oh my gosh, it is quite confusing. Okay.
Alrighty. So we start off with an empty list now, and then we say, well, head is equal to create node.
Yeah.
And now we can change, and now it's called immune order. So let's change that to be do we say 2 9s?
Yeah, let's just do 2 9s. Doesn't matter as long as they're both divisible. Okay, let's see what happens. Okay, so it's deleting the head, it's giving the new head, but part of that reason is because what a few people have said in the chat is we're just deleting the first instance of the condition. We're not going through again and again. So how would we make it continue looping through the list and delete every node that is divisible by 3? That is a much harder problem because you could be deleting every node. But what do you reckon would be the sort of basic structure for it? Okay, so let's have a look. Another while loop inside, or use an if condition. Yeah, okay, we could do that. That's a great idea. Let's try that. Okay, Tom, are you on the keyboards?
Yep.
Let's do it. Okay, we have a condition inside the while loop. So we would, recursion could work. Oh, I'm so proud. I feel like a mother hen. Someone's just, like recursion, throwing it out there. And someone's saying, can we count the number of nodes and then loop that number of times? That's neat too, because you might have to loop through this list multiple times. Yes. Oh, and someone else suggesting recursions just warms my heart. Okay. All right. Fantastic. Oh, I'm sorry. I'm so overwhelmed by the emotion of how awesome everyone is. We're going to run out of time to do this properly. So, what I'll do is I'll make that code available because I wanted to do the next one as well. But that is excellent. And let me put your mind at rest. In the first 4 questions, you will probably only have to loop through once, which is quite nice. And you could use a sentinel the loop as well. Oh, this is beautiful. Just beautiful. All right, it's all happening. Tom, could we please move to the function, the next one, because everything, people are I can't even speak. I'm about to shed a tear. Okay, so one of the examples I had when I was going through what the exam is going to look like, what was this, find the range of the function, which was, find the smallest node in there, find the largest node in there, and then subtract them from each other. So let's do that. Okay, so let's think about how we would do that. So function to find a range of a list, largest minus the smallest number. So we're given this find range, we're given it the head, and then we're going to, I think, use 2 functions, one to find the smallest, one to find the largest, and we're going to work it like that because then we can just return the largest minus the smallest. Okay. So let's do a find smallest first because I don't know, why not? Let's think about how would we do our lovely find smallest function. Oh my God, struggling for words. Okay, let's do it. Oh yes, there are no help sessions during the final exam. We will be running, the forums are still going, so keep studying. I hope keep studying. Shrey has come because he's going to miss you all and he will come and say goodbye. So in about 5 minutes when we stop. Okay, Tom, let's do it. So find the smallest node in the list. What do we need to do when we want to find the smallest node? We want to be able to traverse through this list. And as we're traversing through the list, We want to be able to traverse through the whole list because we want to be able to find what is the smallest node in there. So what is the smallest piece of data in a node that is going to happen for us. So what we want to have, again, is we want to have something that we're going to traverse the list with. And in this case, or in every case, probably you guys have just typed it 1,000 times now, struct node current is equal to head. What do you think would be a good idea here? So if we have a smallest number, what will I need to keep track of what this smallest number is. What would I set it to? So if I have an int smallest for my variable that will keep a smallest number in, what will I set my smallest number to? What do you reckon? Pop it in the chat. Oh my gosh, Tom wants to make a dad joke. I've got to allow it. It's the last lecture. Go on, Tom. Dad joke time.
We're going to need to find a really important number.
Oh my goodness. I'm bright red for you, Tom. I'm bright red for you. But also laughing, so well done.
Thank you.
Okay, so what will we set that smallest variable to? Yep, well done. We're going to set it to the current data. Excellent. So let's have an int smallest, and we're going to set it to the current data because that's going to give us that first node. So I've set it to, let's say I have a current over here that is set to the head, and I'm saying that the smallest one is the first item in the list. Then I'm going to loop through the list. And as I loop through the list, I'm going to search for anything smaller than that head, okay? Oh, Jess has picked up on it. Was that an intentionally? I love it. Okay, so we're going to loop through and we're going to see if anything is smaller than that. So we want we want to go to the end of the list this time. So we want to go all the way to the end, which means that our current is not going to be equal to null to get us all the way to the end of the list. And we're going to be searching for a condition, exactly what I've said it's going to be. Oh my God, Shrey's in on it now, losing the plot. So if any node here is smaller than my int smallest, then I'm going to make that the new smallest, okay? So whilst I'm looping through, if whatever is inside my current data, so Tom, if whatever's inside my current data is going to be less than the smallest, it's good to see that other people also have an issue with smaller than and greater than symbols. Then what do I want to do? Then I want to be able to set that as the smallest number. Oh my gosh, this is the best. There's so many puns in there. Okay, so if we're less, then we make this new smallest number and then we move ourselves along. So let's increment current to the next node. Fantastic, excellent. And then we're just going to return the smallest. Amazing. Okay, and our largest is going to look like something very similar. Okay, our largest, oh my God, no. I can't believe this is still going. Okay, so our largest is going to look something very similar. We're going to have something to traverse our list with. So we're going to have a current that we're going to traverse the list with. It's going to be equal to the head. So we're going to set our largest number to the first node again. And then we're going to search through the list to see if anything is greater than that head. So whilst current is not equal to null to get us to the end of the list, if current data, so if the node is greater than the largest, so if any node is greater than the largest, then we're going to have a new largest. So then I'm going to set my largest to whatever that current data is because clearly it's bigger than the previous one that we've tested to it. Fantastic. And then I'm going to come out of that if statement and I'm going to do my incrementing. So I'm going to say current is equal to current next to move myself along the list. And then I'm going to return the largest number. Fantastic. So let's have a look then if we go to the find range, okay? So in our find range function, we've got a smallest and we're using the find smallest to get our lovely smallest number. We've got int largest, so we're going to use that to find our largest number. Are there any boundary conditions that I need to think about? What do we reckon? Are there any boundaries that we want to think about? What happens if I give it? I think Jess has not just answered the question, but she has also done it in a pun. Amazing. So one of our boundary conditions is what happens if the head is equal to null? What happens if there is nothing there? What happens if there are no nodes in our list? What happens if we have negative numbers? What happens if a whole bunch of disasters? Now, in this case, the find range function, just to throw you off the scent, is returning an int. So what would I be able to return here? What could I return? Thoughts, ideas, suggestions? It's going to cause me some issues because it's returning an int, but in any case, it will be easier to break. So we'll have to return an int because my function returns an int, and then we can see how we could break that. So let's just return 0 in this case. Okay, great. Yeah, all right, excellent. Let's save it. Yep, thank you, Tom. Uncomment that out, save it. Let's run it. Let's see if it works. The final hurrah, the final linked list.
Should we change the main.c as well?
Oh, that would be a really great idea, so we could actually use the functions that we've just done.
Sorry, I know it's a crazy idea, but just maybe. Alrighty, save.
And let's run it. The final compilation, and it was successful. Is that correct? Yes, it is. How amazing. If, question in there, if we're looking to delete the smallest node, would we just run this loop, then free the current? Wondering how to keep track of the previous node to change its pointers. So the way we were doing it in the last question, that's how we keep track of the previous and the current. If you find the smallest node, you could, there's a number of ways to do it, but you could run through, find this node, then delete it, but you have to check whether or not it's at the head, whether or not it's at the tail, and so on and so forth. But you would be able to have a pointer, so as Nicola said in there, so you could return that node. You could return a pointer to that node, and then you could play around with it in that way. And we will put some code also in the lectures of the problem that we didn't have time to go over. And I'll also do one for you that will be able to delete the, if you have to go through and loop through more than once. But I'll give you a few days to try and maybe figure it out yourself. Okay, I just wanted to say a huge thank you to all of you. It's been fantastic. This has been the first time that I've taught 1511. I usually teach later years and a different subject. So I really appreciate it. Thank you so very much. For tuning in, for engaging in the chat as well. And, you're not coming up on Zoom, Tom. I don't know why. Anyway, so thank you. I really appreciate it. I appreciate the engagement of the chat and the fact that everyone has contributed to to the chat as well. It's been really, really amazing. I've had a lot of fun teaching C, I guess. It's been quite interesting because I had done Objective C for so much longer now that some things have floated away from me on C. So it's been quite fun as well to reacquaint myself with it all. I hope that you all go into the exams feeling confident. I hope that you all have a wonderful break over the summer holidays and that you get to see friends and family and enjoy some downtime as well. I want to wish you some lots and lots and lots of good luck for all of your exams and all of your assignments. And I look forward to seeing many of you in your subsequent courses as well as you move through your degrees. But thank you for being, for being quite an amazing student base. The only thing I would have done different is I would have been on campus so I could see all of you. And then you would have seen my manic running around theatres because I tend to move around a lot because I have a lot of energy. But thank you all so much. Good luck. And I think Tom and Shrey both want to say something as well.
Are our videos working for you, Sasha?
For some reason, it's not coming up. Hold on. Let me fix it so that everyone can see you as well.
I just want to say, first of all, thank you very much, Sasha. I know all of the tutors have really loved working with you. And then thank you to everyone in the chat. Thank you to everyone.
Oh, you get to see my dog as well. Sorry.
Sorry?
My dog's now come up in the picture as well. Sorry. Thanks, everyone.
Perfect. Well, thank you to Sasha's dog as well. But yes, thank you, everyone. Thank you to all the tutors as well, who I hope you will get the chance to say thank you to them, because we couldn't run the course without them. Yeah, just thank you to everyone, I think is the summary of this.
It's been very fun to teach you all for the last 10 weeks, and best of luck for your exams. You'll smash it.
It's really got the branding on point here.
Oh,
yes.
yes.
Wants to talk to Shrey about branding.
But half of Shrey's head is missing because of that branding.
Yes, that's all good.
Yes.
Need a green screen.
SW.
All right, everyone. Good luck. Thank you so much. We will see you onwards and outwards to infinity and beyond. I don't know. There's a lot of... I can keep going.
We'll see you all soon.
And we'll finish on that note.